So, just doing this for the late joiners. You've got a cube, we don't know its length, but it increases at a rate of 0.1 centimeters per second. So this gives us that information, and we can call it L or X, but because it says length, and I've labelled the diagram with L's, that means the length, the side length to dt equals 0.1, because that is the rate of change. That's the rate of change here. Now what we want dv dt, because it says to find the rate of change of the volume of the cube at the instance the side length is 5 centimeters. Right, so we need to find what volume is. So volume equals L, I'm going to do L cubed, so it's going to look like a 1. So we should know dv dl equals 3L squared. Now it did give us as L equals 5, so we sub that in. So we can find dv dl, 5 squared is 25, so 3 times 25 equals 75 when L equals 5. Now we do want dv dt, right? So dv dt is going to equal dv dl times dl dt, which we have up here. So that's just going to equal 75 times 0.1, so that equals 7.5. So we know dv dt, because it is the rate of change and it's volume cubed to the minus 1. And because you know, just in case you don't know, that cancels. Are we okay with that? So it's just getting used to the skill. I know we didn't do much work on it, but we okay with that, people? Yep, wonderful. Ollie, I can't hear what you're saying. It looks like you tried to talk. Right, let me just check if I've got my speakers on the right setting, because I can't hear you. Audio device, speakers. Right, yeah, that's my speakers on the right second. So Ollie, I'm assuming you're saying yes, my speakers are now working. Alright, so we should be happy with that. Right, wonderful. So here's another question for you to try. So you can see you've got the skills to do it, and it's just words, but you've got to take the information out of words, which is going to help you with all your exam questions. Right. Question 7. Right, I am going to go through this one with you because new wording makes it very difficult. So I'm going to highlight. So it's got this word direct proportion to the temperature, and do have a read of the question. Finding expressions in terms of R and T for the rate of change of the volume of a glass sphere. Okay. And it would have been unfair for me to get you to do this, so let's go pen, blue. So hopefully you remember from GCSE. But this question is saying that the radius in relation to time is in proportion to the temperature, right? So if we remember this symbol, that is in direct proportion to t. So can you remember we have that constant of proportion? So dr dt, remember it was like y, but we've changed it to dr dt because it says rate equals kt. Yeah? And k is a constant of the direct proportion. Okay? Now, I'm going to write, we want, what the question's asking for is dv dt, which is the rate of change of volume of this class sphere. So that's what we want. But we've got dr dt. So we've got to find v, which is, hopefully you remember, the volume of a sphere is 4/3 pi r cubed. So we're going to get dv dr, which when we multiply these two is going to give us dv dt equals, multiply it out by 3, so that's 4 pi r squared. So we know by the chain rule dv dt equals dv dr, which we've just found, times dr dt, which we've got. So we substitute all that in. I'll make this r just look a bit better. So that means it's going to be kt times 4 pi r squared. So you can see this is a slightly more difficult question. So we just simplify that to dv dt to 4 pi, we don't know what k is yet, k, we've got t, r squared. Okay, so that is part A actually. So for part B, we read the question, when the temperature of the glass is 1200, a glass sphere is 2. Okay. Now, be careful because we've got T here, so look at my mistake. That should be really a big T, right? And that's a big T. Because of that. But anyway, let's go back to B. So it's saying the temperature is 1200 when R equals 2. Now, its volume is increasing at a rate of 5 centimeters per second. So that is dV little t with respect to time. It's not nice that they've used these letters in a way. So dV to t equals 5. We should be happy with that. Now from here, that's why that's big T. We know dV dt equals 5. So 5 must equal this 4 pi k, 4 pi k, and we have what t is now, so we can just write times 1200. Why is that doing this? 1200 times 2 squared. So we're going to get 5 equals 19200 pi k, and then we're going to find out our constant of proportion by rearranging that to get 1/3840 pi. Right? Now this is find the rate of increase of the radius at this time. So that's what we're doing. So the radius is going to be dr against dt, right? So we're trying to find dr dt. Now, remember at the very beginning we found dr dt equals kt, k big T. So we just use our figures, 1 over 3,840 pi times 1,200, which equals 5 over 16 pi, which is going to equal 0.0995 seconds per second to 3SF. So that you could see is just applying all your skills. And do we have any questions about that? Yes, because of that new word, right? So it's applying that skill. But I wanted to show you it because it is tricky, but you have to try to do what you can. But like I say, this is why it's a challenge. It is a bit confusing. It's because that direct proportion to temperature, then you've got the change of volume, then you want the change of radius, but you have to break up each step to do it. But I agree, but that's what's challenging about this, because it's so many steps, if you make sense. But that is a medium style exam question. As long as you can do some of it is our aim, and you can get some method marks, alright? But hopefully you can look at the video again and it'll break it down for you. Right, so now we're going to use the same skill, but when you have to use a product or chain rule in the question, right? So I just wanted to show you something scaffolded a bit more difficult, a bit more. So I'm going to give you this question here, and I think you can give it a go, but if you look here, that you can see you've got to do separately for when you do dx dt and dy dx here. It's asking you to find out. Remember, that's just using the chain rule twice, chain rule here and chain rule here, and it says, and this will link to dy dt, because you can see when you multiply these together it makes dy dt. So I think you can give that a go. Right, I'm just going to do y one first. So if you think, what I'm going to do is, how you do this, you would set y equals 6u. Sorry, 6e to the u. So u equals a half x plus 1. I will say du dx equals a half, and dy du equals 6u. Six e to u, I mean. Okay, and then so dy dx is going to be these two multiplied together because of the chain rule. So that's just going to be 3e to the u, sub u back in, that's going to be 3e to the half x plus 1. And I'm assuming you found the x dt, which if you use the the chain rule on this, you should be getting 2 to the 4t plus 9 to the power minus a half. So Nia, does that answer your question? Well done. So that's good. That's, to be honest, that will get you 2 marks for doing that and 2 marks for doing that. So we've got 4 out of 4. And even you got a bit stuck, now you can get 4 out of 4. So that's progress. So that's nice. We've got dy dx, which we're going to need, and dx dt. So for part 2, that's part 1. Let's change colour for part 2. So what have we got to do for part 2? Well, dy dt is going to equal, what's up with my pen today? Obviously dx dt times dy dx. So we're going to get got to keep the brackets in, 9 to minus a half times 3e to the half x plus 1 Now we can simplify that by just doing the 3 times 2 on the outside, so we'll just make it a little bit nicer for us to substitute in later. So that's 6 4t plus 9 to the minus a half times e to the half x plus 1. Just put a bracket there so we know that's all together. Right, so we're almost done. Now, what's the problem here? Oh, I wasn't supposed to start that off for you actually. But now, what's the problem here? Because we've got t and x in the equation. So, first step is t equals 4, so we have to use t equals 4, and then have a think, guys, because this could happen to you. What do we use when t equals 4? We know we have to use t equals 4, but go Ollie.
Would you sub 4 into t?
You would, and that would be a part of it, but can you see here, if you can see my pencil, let's highlight this so you can see, but can you see how we're going to find the value of dy dt when we've got this x here? So how are we going to change this x into t? This is the key part to getting full marks on this question.
Do you have to use logs?
No. So just a little step, but I know people miss that out when you're under pressure. So, good try though. Right. Any other ideas? It's good to have a think. Because we need this in terms of t, right? So, is that...
I've got a question.
Go
on. How come when you differentiate 6e to the power of u, does it become 6u to the power of e?
What's this? This one here?
Yeah, in the first part.
And why does it stay the same?
Yeah.
Okay, because, do you know e to the 2x? And so if you get dy dx, you know that becomes 2e to the 2x, right? But when it's y equals e to the x, dy dx is still e to the x. So because it's just u, it stays the same essentially.
Oh, okay. Thank you.
So, any ideas about this? Because you're not going to be able to get the final answer and lose a method mark. Have a look at the whole question. What can we do?
Wait, do sub in x equals 4t plus 9 to the power of a half.
Yes. That's how you unlock it. So what you're actually doing is... But you can't do the question otherwise, right? So e to the half bracket 40 plus 9 to the power half plus 1, and then you can kind of right, and then you can do on your calculator t equals 4. And what do we get? Yeah, and actually writing that is worth an answer mark. Sub t equals 4 in, you should get 39.7. Now, as that's quite a long time, you can mess that up on the calculator. I want you to try that on your calculator, make sure you can get that. And if you got that, then that's perfect, because then you can get the final answer, or accuracy mark we call it. Right, are we getting that on the calculator? Yeah, Vanessa, good. Well done, see your thumb. But obviously that's important, you can make a mistake. Well, did we get 39.7 on the calculator?
I'm still
Okay.
in it. Okay.
Yeah, okay, let's see you got it right. So, whilst Ollie does that, can you see this point here, key point, you get up to here. Now, how many questions is that worth? How many marks is that worth? 3 mark question. Well, you'll get 1 mark for this, but you'll lose 2 marks, because this is worth a mark and that's worth a mark. So that little bit of spotting that half x, we don't know what x is, but it's up here, and we substitute that in, so it's all in t's, and then we can do it.
Yeah.
Okay, wonderful. Okay, so right, now I'm gonna let you try this question yourself, and when you need a hand, I will start working on it, if that makes sense. See this bit here, got to use the chain rule on that, and I'm gonna pause the video, give you a shout whilst you do that. So we're finding dVdh. So here we go. So I'm just going to change that to y equals h 6 plus 16 to the half minus 4, so we should be good at this. We're going to let that become y equals u to the half minus 4, and u is going to equal h6 plus 16. So dy du equals a half u to minus a half, and du dh equals 6h to the power 5. We're going to combine that together to essentially just get dv dh here. So that's those two multiplied together, which is obviously a half u to the minus a half times 6h to the 5. Substitute what u back is into here. So part 1 dv dh equals h to the power 5 times h to the 6 plus 16 to minus a half. Sub h equals 2 in, and we get dv dh to equal 10.7. So part 2, I'm going to highlight that. That bit means dv volume over time, but it's per hour. So dv dt is actually going to equal 8. And I think just recognising that gets you a method mark. So why is that doing that? Oh, I've lost, my pen's lost signal. Okay, that gets you a method mark. Now this second part, it's saying find the rate in meters per hour at which the height of the pile is increasing at an instant when h equals 2. So we are essentially trying to find dh over dt. That's a question mark. So hopefully we know dh dt is going to equal dv dt times dh over dv. Okay, now from part 1 we have dv dh only, which equals, where did I write it neatly? Here. 3h to the power 5, h to the 6 plus 16 to minus a half. But can you see this is dv dh? But to get dh dt, we have to flip this round, right? So that means dh dv is the reciprocal, is just going to be 1 over 3h to the power 5 h to the 6 plus 16 to the power minus half. That's the key point to unlocking this question. I should have changed colours really. Right, so this in fact is going to equal 8 times what we've done here, 3 h to the 5 h to the power 6 plus 16 to the power minus a half sub h equals 2 into the formula, and let me know what you get.
I've got 0.75 for two figures.
And that is perfect. So dh dt equals 0.75, and yeah, that is what it is. So well done. So Ollie, you remember to flip the DVDH, right?
Yeah, I did.
Good, because that's easily missed. So well done you. Look at what you did there.